Today we're going to be learning about the neuron and how it works and how it is able to transfer chemicals to electric energy back to chemicals in order for us as human beings to perform actions and other daily things. So the first thing that's going to happen is you have the cell body here and you have dendrites hanging off of it, and each dendrite is going to have receptors on the end of it that are going to receive a chemical energy from the neuron before it and then transfer it into an electric signal for the rest of the process to begin. Another way that you can think of the receptors receiving the chemical signal is in baseball. When somebody catches the ball, you can just picture the chemical signal as that ball and the receptor as the glove. So here we have the cell membrane. And on the inside of the cell, we're going to have our proteins as well as our potassium, or K+. And on the outside of the cell, we're going to have Na+, or sodium, as well as chloride. And currently, the charge of the inside of the cell is negative 70 millivolts. And this is before the neurotransmitter has hit the receptor. So once the chemical signal hits the receptor inside the cell membrane, the K channel is going to close and the Na channel is going to open, and as soon as this channel opens, Na is going to rush. Currently the K plus channel is open and the Na channel is closed, and what's going to happen is the K plus is going to move in and out of the cell as it wants, and this is due to the diffusion force, which is basically that like particles don't want to be next to each other and they'd rather spread out. Once the receptor receives the chemical signal, the K plus channel will close, the Na channel will open, and as soon as that channel opens, Na is going to rush inside the cell, and this is both due to diffusion and ionic force. And ionic force basically states that opposites attract, so the negative charge within the cell is attracting the positive Na ions, and as soon as they rush the cell, the charge within the cell is going to jump to positive 40 millivolts. So the next thing that's going to happen is the Na channel is going to close and the K channel is going to once again open, and as soon as this K channel opens, all of the potassium is going to want to rush outside of the cell, and this is once again due to ionic force, because the positive charge within the cell is going to make the K plus want to leave. And so once again, the cell returns to a negative 70 millivolts as soon as all of those positive ions leave. So currently we have Na on the inside of the cell and K plus on the outside of the cell. And in order for the cell to be able to fire again, it needs to reverse those so they're on the correct side of the membrane again. So it's going to shut this K channel, and the pump is going to kick in, and what the pump does is it simply cycles K for Na until they're both on the correct side again, and the inside of the cell is currently a negative 70 millivolts once again, and it's going to just keep switching these until they're all on the correct sides. While all of this is happening on the cell membrane, once it returns to firing capacity, it's going to move to the axon hillock, and if it reaches negative 55 millivolts, then the electrical signal will be allowed to pass down into the axon and through the myelin sheath. Taking a closer look at the axon, as soon as the axon hillock decides that it's going to fire the signal, a ton of Na plus channels are going to open all along the axon, and Na is going to rush inside of this tube, and because it's so small, it's going to get trapped, and there's going to be negative charged proteins all along the axon. And what the myelin sheath does is as soon as it goes in here, it's going to get trapped, and then it's just going to want to go to the next negatively charged thing, so it's going to appear like it's shooting down this node, even though it's not actually shooting, it's just moving as fast as possible to get to the negatively charged ions down here. The last part of this process is going to be at the end of the axon, and what's going to happen is this electric signal that's been jumping down the axon is going to hit all these vesicles at the end of the axon, and it's going to tell them to release their neurotransmitters, which are the blue dots that you're going to see. So once these neurotransmitters are released, the next neuron is going to have its receptors all along, and these neurotransmitters are going to fill the receptors. And as soon as the last receptor is filled on the following neuron, then the autoreceptor on the previous neuron is going to catch a neurotransmitter and tell this neuron to stop firing. And the point of this is to save energy for the neuron. And what's going to happen to the extra neurons is they're either going to be taken into the reuptake channel or they're going to be eaten by enzymes. Going back to the baseball metaphor earlier, we can think of the receptors on the receiving neuron as the first baseman and the autoreceptor on the previous neuron as the pitcher. So the first baseman is going to receive all of these, but as soon as the last one gets to the pitcher, so at the end of the play, everything's going to shut down, just like a play in baseball.